Welcome to the 8th and final week in the Learning Analytics and Knowledge Open Online course. This is actually coincidentally also our final presentation in this course as well. We're particularly pleased today to have Marie Bienkowski join us. I think I met Marie the first time, it was about 1.5 years, 2 years ago at SRI, and where we had an opportunity to have some discussions around learning analytics and educational data mining, and she's one of the authors of the influential Department of Education report looking specifically at educational data mining and learning analytics. And so she's very informed on these topics, and it's a pleasure to have her involved here. So on that note, Marie, I'll pass it over to you. Welcome.
All right, thanks George for that introduction. So what George asked me to talk about today is a project that we've been working on with funding from the U.S. Department of Education and the U.S. Department of Defense called the Learning Registry. And I did want to take a minute to acknowledge not only the funders, but also the people from the open source community who were contributing to the project. A special call out to the National Science Digital Library folks, the JISC JLearn experiment in the UK that did quite a bit of work with the piloting the learning registry and setting up nodes, and then also a small company here in California called Navigation North that did some, served as early testers for some of the technology. So now I'm going to try to go to the next slide, and I realize that must be that. Okay, so why are we interested in, why should we worry about learning resources? You hear a lot about open education resources, and I wanted to take a minute to give you a little bit of context that helps me get out of bed in the morning when I'm thinking about education. So I think the tide is actually turning, and we're starting to see that some of these traditional education practices are starting to fade. This idea that you have to have these hour-long classes where there's a seat time requirement, students are lectured to, they're grouped by age instead of ability, and that you've got this sort of paper textbook as your primary learning resource, no cell phones. And really what's of interest to this group is the kind of open feedback loop that you find in some of these places. So what we think the trend is toward, hopefully, is this idea of deeply digital learning, the flipped classrooms, is more engaging, game-based learning, badges that you get for competencies. You have learners collaborating by ability and interest in what's relevant to them. And then this idea of these data ecosystems where you have these highly instrumented environments, including leveraging the internet of learning things. So analytics and data mining, I think, has a lot to offer in that space, as you've probably been talking about for these past weeks. Really seeing it as a way to do continuous improvement of courses, curriculum, and applications through things like A/B testing. A lot of people are starting to work on more continuous testing and stealth testing. And some of the things that we're really interested in for the Learning Registry is this idea of recommending online learning resources so you can build your own pathways. And I have a little screenshot here from the Newton system that shows a particular pathway that this student took in learning in this math area. And then another thing that we can focus on with these large amounts of data is helping students regulate their own learning, getting the right challenge, the right encouragement, and the right engagement as they're going through learning experiences. So that's kind of the big motivation for our work on the Learning Registry, and you'll see we'll be getting down into the weeds a little bit more, but always trying to keep in mind the end goal of the student. So what I wanted to also let you talk a little bit about are some of the problems that we've been seeing with the ability to do personalized learning and recommendation systems. So you have these repositories. A lot of people in the digital library community have been very active in building up repositories, but they tend to be really stovepiped. and they're really not, they're sharing data through these pipes that they connect to each other with, like OAI PMH, for example, these harvesting protocols. And what happens is, what the observation has been is that people don't update metadata. They don't care. They won't add it at the outset. They just dump their, they link to their website and don't really do any descriptive work about what that website does for learning. And then we have this observation that there's this data exhaust that's out there. People are doing things on the web. They're doing learning in classrooms. And all that exhaust is really not going anywhere. It's not powering any kind of future work in learning or improving learning. And so what you find is that there are a lot of learning resources out there, and this is really why the Department of Ed was interested in at the outset. And they're really, these learning resources are developed, they're federally funded, they're funded by federal agencies in the United States, and they're just languishing on the shelf because the data is locked in and locked down. And what we'd like to think of instead is, instead of having these stovepipe repositories that share, hold data and share via these pipes, that we've got data that's shared in the open so people can aggregate it, they can amplify that data, they can do analysis of it, all toward this goal of improving the access to learning resources. So instead of having this kind of stale metadata where people say we can't even plan on good metadata at the outset, we want to think about enriching this data pool, this metadata pool with social usage data. This is also called attention data, metadata, or paradata, to really add nuance to metadata and to start to harvest some of the kinds of analytics that we're seeing from sentiment analysis, for example. And instead of wasting this data exhaust or having it not be powering anything, we want to have it collected to power the social life of a learning resource so it can get a little bit more, a little bit better play for learning. And instead of having learning resources languish on the shelf, we want to have them live in a rich ecosystem where they are used, people know how they're used, the developers know that they can be improved, and of course we can benefit personalized learning in this case. And then of course we want to have democratization and liberation of the data instead of it being locked in and locked down. So the Learning Registry was conceived of as a way to put data into the open for aggregation, amplification, and analysis. It's a distributed system, so it's a set of nodes that pass data amongst each other, and it permits you to share metadata about learning resources. It was developed through an open source process, and we've engaged a number of different community members throughout the couple years that we've been working on this. We've been talking with learning resource creators, so people who want to publicize their open educational resources, but also publishers, so people who want to be paid for the work they've done on creating educational resources, people who curate, people who and people who consume and want to give some feedback into the system of improving learning resource use. So it's a story-forward data exchange network. Technically, that's what it is. And it's often difficult to explain to folks what the Learning Registry is, because there isn't, although we have a web page, there isn't really a place where you go to use the Learning Registry or to log into the Learning Registry. It's not a search engine, it's not a repository, it's a registry of metadata information. But what we envision is that you can have diverse user services be built on top of the application interfaces that we've created and then that use the data in the Learning Registry. So this is addressing the problem of being able to enrich the learning resource data with paradata or attention metadata to add nuance to metadata. So here's an example of how the Learning Registry might work. So the middle column shows the Learning Registry where you have metadata, and it's actually stored in a timeline. So you could do, for example, a trend analysis from the data that's in there. And so we've got a couple of players that we've used in this representative scenario. So the U.S. Naval Air and Space Administration, NASA, has some interest in getting kids excited about STEM, science and technology, and so they've got the Mars rover, and they want to have some learning resources about that. So they might go ahead and post a message to the Learning Registry that says, hey, I've got some metadata about this Mars rover animation. Then the National Science Digital Library, which is a U.S.-funded digital library of STEM education materials, could say, hey, there's a, through the Learning Registry could discover that. So there's some discovery that's happening here. And say, well, that looks really good. I'm going to take that resource, find its get its metadata from the Learning Registry, and then you provide that resource to my users. But you could also have a teacher portal, and that's what this CTE Online represents. That's a website that Navigation North has created for career and technical education. So they know that design thinking is very important in career and technical education, so they want that Mars rover animation, so they pick that up from the Learning Registry. And then NSDL has a user-facing website, so they can go ahead and have a teacher that actually comes to their website, and that teacher can say, oh, I like this NASA animation, and that information can be fed back into the Learning Registry for later use. A career and technical education teacher can actually say that that NASA animation aligns to a standard, a curriculum or a learning standard, and then that information can be put back into the Learning Registry. So you've got this timeline of metadata, descriptive metadata, and social metadata about learning resources that then at the bottom we show these cloud service providers that can take that data. They can aggregate maybe life data that allow teachers really to share their opinions, because teachers are often isolated, especially in K through 12, which is kind of where I had been a lot. You might have alignment data, and I'll show a little bit of examples of that later, and use that to improve searching, so you can search on alignment data for standards, or maybe doing analytics on the social metadata, as I show on the right, service provider that just provides advanced recommendations. So that's kind of a scenario, a day in the life maybe of a learning resource as its metadata goes into the Learning Registry. So the next slide shows some of the way that we can reify this idea of data exhaust, where we're trying to collect it to power the social life of a learning resource. So this shows annotational, kinematic, and pedagogical paradata. And this list was created by the National Science Digital Library interacting with teachers and asking them what kinds of things they thought would be useful to know about learning resources. So there's a kind of a whole refinement of this descriptive metadata where you're rating, you're commenting, you're voting. There's diffusion through user actions, you're favoriting, you're downloading, you're sharing to social media. So that's moving it around. There's also pedagogical paradata where you're actually looking at the educational content and the utility of it. Has it been aligned to a standard? Is it embedded in a learning resource? So you could see that if we knew this kind of thing about learning resources and we could harvest that, how much more useful would it be for a particular learning resource? And what we've observed is that you have these popular learning resources, like the NASA Mars rover happens to be very popular, and it shows up in a lot of different places. There isn't just one repository where you find it, but there's no place to go and aggregate all that information together. So what we want to do is use the Learning Registry to let resources live in this richer ecosystem where you can actually look at something like the Mars rover and have a summary. This is a mock-up. This is not an actual an actual website, but you can imagine having the resource information, having usability ratings, accessibility ratings, tags that people have put on it, voting schemes. So this kind of shows the power of the data that we could pull out from the Learning Registry. So I'm going to show one more example, and then I think I'll take a break in case there's any questions. So here's an example of what this might look like, and this example is especially of interest to teachers because they often, when they're looking to put lesson plans together in the K through 12 space, are they're trying to innovate in their practice. They're trying to find interesting things. They're trying to find things that are online, but this data has not yet been liberated until we can pull it out of the Learning Registry. So this is an example Chrome plugin that we built that actually amplifies the Google search. So you see we did a Google search for interactive volume and surface area. And what happened is the plugin queried the Learning Registry to see whether the Learning Registry had any metadata or paradata about this particular resource, indexing on the URL, and then it inserted into, and this is legal still with the Google search page, inserted into the search results information that was about this resource from the Learning Registry. And so this is kind of the canonical example of how we see this. The data can be extracted from all these disparate sources, put into this data pool, and then pulled back out in this useful way where it's cutting across really these different stovepipe systems. So I'm going to go ahead and pause right here. This is another example of recommending resources based on alignment data. And I'm just going to check the window here, and I don't see anyone in the chat. So I'll just type in here in case somebody can see me. Any questions? Thank you. Okay, a place where we can get your slides. Okay, yes, I can. Okay, so I can provide the slides. I have to realize I still have the floor. Okay, so there's a very interesting question about the statement of the problem and how we get the different stovepipes to cooperate. And there's also a question about OER Commons. So it is true that bootstrapping the network effect is a tricky problem here. The cooperation is really pretty simple. All they have to do is really dump their data into the registry. There isn't any you say cooperation, and that maybe that's not the right way to think about it, because really what they're doing is just sharing their data. Now, we have had some folks who feel like maybe sharing their data is going to you know, give someone else a competitive advantage over them. But if these are open educational resources and we're all in the business of trying to get them to you know, be located so that we can, you know, benefit education, having a cron job that runs once a night that takes your updated data and puts it in this Learning Registry isn't a big burden on your system, and it will help you know, the curation that you've done. It will help those resources be more findable. It's true that it wouldn't necessarily direct traffic back to your site, which is often what people want, but we're also hoping that the idea that you know, people want to benefit education, and that should be a place where we're sharing, is what's going to motivate people to participate. So that was the stovepipes. We'll get you the slides. So OER Commons is a little bit different, because that is a that is a repository that is being curated by the ISKME folks who run OER Commons, and they are actually publishing their metadata into the Learning Registry. But what's interesting about OER Commons is they do have a rating scheme and a favorite and so on. But if you go to OER Commons, you'll see the Mars rover. If you go to NSDL, you see the Mars rover. If you go to a National Council of Teachers of Mathematics, you see the Mars rover. And the point is that getting them all to share data would require an N-way collaboration. And this way, with putting it all in the Learning Registry, we can make it all available. So it's similar in the sense of the kind of social metadata we're collecting, but not in terms of the functionality. The Chrome plugin currently is, I think it's in the Chrome store, but I don't know if we've updated it with some changes that Chrome has made. So I can pass that out to George so he can post it in the course. And then the standards, Open Systems Right to streamline access and analysis of disparate stovepipe data. Let's see if I have, if I answer that as we're going through the rest of the talk. And then if teachers do not care about metadata, it's actually not the teachers that don't care about the metadata. Interestingly enough, it's the providers of the learning resources and the people who curate learning resources that often have trouble getting metadata in, or have trouble getting the right metadata. What's the right grade level for this? What's the amount of time it should take for a student to do it? What kind of language skills does it require? So I think that what we're hoping is that the Paradata gives you a kind of more up-to-date, continuously up-to-date information, so that they would start to care about it because they see resources that are more relevant kind of bubbling to the top. And I'll show some examples of that when we talk about the alignment data. Okay, so I'm going to hope that answered questions, and I'll try to get to the standards question as we're moving along. So I think this is what I've been talking about, where we've got these different learning resource systems that are generating this kind of data that can be connected to the Learning Registry network, and we've got these publish and consume APIs. You can work with learning object repositories like OER Commons and NSDL, teacher portals like mathematics portals, or I think the National Archives has a teacher portal for their learning resources. Search tools, I showed the Chrome plugin. Learning management systems, we've been talking about hooking up with them. And also I mentioned here instructional improvement systems, because some of the states here in the U.S. are interested in instructional improvement and are building these large data systems, and are being asked to participate in the Learning Registry as part of their improving their practices, not just within a state, but across states as well. So that's pretty exciting for us. So I just wanted to give you a little bit of a picture of some of the data. This is a couple years old, and I didn't have time, unfortunately, to regenerate it. So this gives you a sense of what kind of data is in there. We have a lot of science data in there because of the extraction that we've been doing from the National Science Digital Library and the some other STEM-oriented sites. But we've also got work on literature, American democracy, algebra, that's algebra and functions, not algebra and fun, even though we know algebra is fun. There is some of the UK data that is put in here is kind of in the lower right-hand corner. So this gives you a picture of what kind of data, what kind of metadata we have currently in the Learning Registry. So a little bit of technical detail. It's built on a document distribution system called CouchDB that uses a NoSQL database system for managing the document data. It is metadata agnostic. We're using a JSON key value representation to encapsulate metadata in any schema. It doesn't mean that we're translating metadata into these JSON formats. It's just an encapsulation. So we put a little bit of writing around the metadata that's things that are specific to the learning registry, and then store the metadata in the learning registry. The social usage data is modeled initially on this NSDL COM-PARA, and also a effort that was started to allow people to kind of RSS-style broadcast their activity using activity streams. This, I think, was before Twitter was actually started. The thing that's a little tricky that I'll mention here, full disclosure, is that we're using the URL for the resource. We struggled a lot with how to do how to uniquely identify a learning resource, and the URL was what we kept coming back to, because one of the design principles that the Department of Ed was very insistent upon was that there be no centralized authority or centralized registry. It is a distributed node system, and they didn't want any single point of failure or anything that the Department of Ed would need to keep, say, funding after the startup funding went away. And then, of course, we've got the problem of people submitting things they shouldn't be submitting, with URLs to things that people shouldn't be looking at if they're teachers and students. So we have a digital signature system that's actually based on PGP, pretty good privacy, that does submitter identity verification with this digital signature. So I wanted to talk a little bit about the Paradata schema, because this is where some of our leading edge work is in. This gives the schema with the this is based on the activity streams, actor, verb, object, and then what it's related to and what the content is, some human readable string. We're using this for things like alignment data, number of occurrences, start and stop time, context of where the learning resource was used. Was it used in a second grade classroom? Was it used in an informal learning environment? And we're finding that this needs a little bit of an extension, so we're actually working on version 2, because we need a little bit more description in the actor field to describe more than just a string description about the actor. Because we want to make sure that we've talked about wanting to build trust networks based on this, and you want to have a rich description of what the actor is if you want to actually, say, try to decide whether an alignment they did from to a standard, a curriculum standard, has some weight. If a teacher does the alignment, that gives you one kind of feeling of how much you should trust that alignment. But if a district curriculum person does it, you have a lot more faith in that. So we're actually doing a refresh on this based on some work we're doing with folks who really have a strong interest in doing Paradata. So that will be extending. And I want to talk a little bit about, briefly, about data services. This is a kind of a broad brush overview of the Learning Registry. Generally we have these, I show on the right the kind of familiar to digital library folks interfaces that we provide. Obtain, Harvest, the OAI PMH. We also have a interface that we call Slice that lets you cut out whole chunks of the learning registry based on things like alignment to a standard, or a tag of a particular type, or a submitter, so you could pull out all of the data that the Smithsonian has submitted, for example. But and this shows the distribution going through the Learning Registry network. And what we're trying to do is build data services on top of that that give you another level of abstraction beyond the obtain and slice and harvest harvesting applications, and then the publish and sort publishing application. So that's kind of the obligatory slide for the digital library community. And I think it doesn't work. Okay, and so I wanted to just acknowledge and give you some pointers too, and it'll be helpful, especially if when George posts the slides, that we do have some people that are very active adopters and experimenters, so Navigation North, and you can go look at their Common Core Lab site. In Bloom, in the what used to be called the Shared Learning Collaborative, is using it for their student integration systems to support the infrastructure for a search and a browse function for digital resources. There's a link to the JLearn experiment that was completed in the UK. I think it was University of Manchester, and then the State Improvement Systems is work in progress, so I don't have any links to that yet. So I wanted to take a minute. We just did a proof of concept internally in pulling some data out of the Learning Registry that's that's doing recommendation by building these network graphs. These weren't necessarily social network graphs that we were doing, but these are just some examples of what you could do with Learning Registry data. So let me jump in and show. So our example here, again, showing the kinds of data that we anticipate, especially for the state improvement systems and for the in Bloom work that's going to be really important. In the United States, we had for a long time separate states each had their own standards. So Utah had standards, California, Florida, and they had spent a lot of time aligning their resources to standards, different learning resources to these standards. And now we have this new thing that's come in where a state consortium has agreed to adopt a set of common standards for mathematics and English language arts. These are the Common Core standards. And so what we believe the Learning Registry can do, and why these state improvement systems are using it, is that they can help locate resources by doing crosswalks among the state standards. There's a Utah Math Standard X, and if it's the same as this Common Core standard, then a teacher in Utah knows that they can use that learning resource, say counting to 50, to match that or to help a student achieve that math standard X. So for a while, as teachers are getting used to these Common Core standards, they can still kind of fall back on their old familiar state standards. This also shows some favoriting and rating data as well. And then here's a more complex aggregation that we've done. We've actually built this in a graph database called Neo4j. Jim Clow was the lead architect and lead designer of this. And you can see that we have a much more complicated situation, but it also provides us with more opportunity to do things like collaborative filtering. So if if I'm an educator and I favorite a learning resource, and I know that learning resource is aligned to a standard, I might want to see other learning resources that are also aligned to that standard. And if two educators both take some action, either rating or favoriting a particular learning resource, we might want to do a collaborative filtering application where we share with educator A what educator B has been looking at, and share with B what A has been looking at. And this gets us to the canonical Amazon.com space that everybody uses as a canonical example of collaborative filtering. So we've actually built this in a Neo4j with an extract of learning registry data, and we don't have a big user interface on it, so it's not something I can demo. But I do have a pointer to a forthcoming book chapter we have about this. So what's next? So I'll wind up here and leave some time for questions. We are working on, sorry that got cut off. We are working on more recommendations by clustering users based on their actions. We still have work to do on identity. Using URL is not quite working. We're having to do assertions that a URL, let's say OER Commons, is pointing to the same URL that at some place like the Smithsonian. We're still trying to bootstrap and get this network effect to really take off. I mentioned the fear of loss of competitive advantage. We haven't done performance statistics on the Neo4j work too, so that's something we're starting up now. We did say we're metadata agnostic, but we are trying to tip our preference to the Learning Resource Metadata Initiative, which we see as having a lot of promise because of its adoption by schema.org and the potential for micro-tagging to let search engines pick up learning resources. But we think even if search engines are able to find learning resources as easily as they find recipes, we're still going to need the learning registry because they're not going to be aggregating social metadata for resources. There's also a pointer I gave to an interesting extension that we're doing with a company, a nonprofit called Benetech, which is looking at accessibility metadata. And if you go to that wiki page, you'll see the a proposal that they're making to schema.org that's aligned with the Learning Resource Metadata Initiative for metadata to mark up resources that are accessible to students that have those needs. And we're also starting an effort when we're doing our Paradata refresh to put accessibility paradata to find out what people want to say about resources that are accessibility in the social metadata sense. So that's it. These are references. The book chapter, the book should be out in a couple of months. We have a educational technology magazine. If you're interested in more information about the work that JISC did, and you want to see some scenarios of how they use the learning registry, that Towards Network Knowledge paper is a good one. We had our LAK paper from last year, and then lastly I list the GitHub site for the learning registry, in case you want to go check out the code and the documentation. And then finally, I just wanted to make sure I gave a call out to the folks who provided these slides, and also the people who are the main GitHub committers, Jim Clow from SRI, my company, and then Walt Grotta, who's with the Advanced Distributed Learning Lab at the Department of Defense. So I have a few minutes for questions. Okay, so the application that allows you to browse learning registry data, we've got a couple that need to be refreshed with the new, you can't really browse it. Let me say that. What we can do is we can pull out aggregate statistics like the box diagram I showed. I think the In Bloom initiative is probably, I'm going to go out on a limb here and say within a couple of months of having a browsing application, a browse and search application on top of learning registry data. And then an ideal outcome for the impact of the learning registry once it's done is really in you know, my best scenario is one in which people agree that for at least open educational resources, it's important not to just try to drive traffic to your site, but to make the resources discoverable, and that we can support teachers in putting innovative learning resources into their classrooms, and that students who want to do kind of self-paced learning or explore more things on their own can find these resources that are appropriate for them. So it's really all about the sharing, and that would be the ideal outcome, is that people are continuously sharing this information. I'm a big fan of the Bitly website, and I always hear talks from Hillary Mason about how she's doing interesting analytics because of what people bookmark on Bitly, but all that information is inside Bitly. No one else, to my knowledge, has access to that. So it would be wonderful if they would open up anything that they thought was educationally oriented and put that information into the learning registry for everyone to use. So the so the question is the LRMI schema supported by the Learning Registry. We support all schemas. What we're currently doing now, when I said we're going to tip the balance toward LRMI, we're creating a schema validation tool that will let you publish LRMI schema formatted metadata into the Learning Registry, and we will validate it because the in-Bloom search and browse functions want to have, or they depend on having well-formed LRMI data, and so we're going to build that validation format for them, that validation tool for them. Okay, so the quality of discoverable resources is an interesting question, and it's that maybe I should have said that was my ideal outcome for the impact of the Learning Registry. Now that, thanks for that plant, John. Really, what we'd like to have is to discover what makes quality, how we could define quality. We'd think it would be by usage, but that's hard to do unless you're putting it into a learning management system. If a teacher just sends their kids to it, you get all of a sudden you get 50 or 30 hits. That might mean that you've got 30 kids in a classroom that are actually looking at that. We also think that ratings are important. Peer review is a little bit more of an involved process, and I know OER Commons has a quality rubric that they've been using that will let teachers do a more structured review of it. I think the point is that it's to be discovered, and right now there's no way to get that information out, and we're hoping at least to provide some kind of forum for people to give that sort of feedback, not only for quality, but we also think the accessibility paradata will be another thing that's of interest to a lot of people. Because there it's pretty high stakes if you go to a resource and it's not doesn't have closed captioning, it doesn't have a font that you can use, things like that. So the Common Core alignment. Okay, so let me see. Does the Common Core alignment among states, I should be repeating the question, provide how the standards for each course in each state are equivalent? So the Common Core alignment is really aligning a standard to a resource, and what you do to say that state standards are equivalent is something called a crosswalk. And the people who are doing those crosswalks are professional curriculum developers, and then we're taking those crosswalks and putting them into the Learning Registry for people to use. So there's another question about Drupal, and I think the differentiation between the Learning Registry and Drupal is that the Drupal is a content management system, and this is lets me make an important point. Learning Registry is not a content management system. It's a metadata management system, which is why we called it a registry, because it's not the learning repository. So we are not dealing with any content. The learning content is hosted on the sites that created it, or where the URL points. So we're not doing any kind of harvesting of content. Okay, so Slice as a stream feed API, I would recommend that for that question, because we are running out of time. What Slice does is it does do a stream feed, but it doesn't do it on a continual basis. So you can't set up a recurring feed that does that filter, like an RSS feed. It just does a one-time delivery of the sliced resources. So we have other APIs, filtering APIs, that would let you do that kind of more RSS-like a stream feed. Okay, Learning Registry and Tin Can is another good question. Tin Can, the folks who worked on the Paradata specification and activity streams were also the folks who were working on the Tin Can API. And you can submit Tin Can statements to the Learning Registry. I haven't looked at their schema in a while, so I don't know how harmonious it is. But it's a very good reminder that I do need to look at that, especially as we do our Paradata refresh activity. Okay, I'm going to send it back to George, because I think just running out of time, and I'll need a little bit of transition time here too.
Well, thank you, Maria. I think that was a very informative talk, and certainly given the increased attention now to a variety of ways to try and provide academics with a better level of analytics, whether it's through a distributed system such as Learning Registry, or whether it is through some of the activity that's now going on out of drawing a blank here, the activity that's happening with the LTI initiative with IMS, Tin Can. So it's interesting to see just the amount of activity now in trying to gain better opportunities for data to be shared between systems across silos, but also to add Paradata layers that gives greater insight once we get down to the actual analytics activity. So thanks very much, Marie. Safe travels, and take care.